Right, welcome back. In the last video, we learned how to apply substitution, and we learned how to apply it if we're given the correct choice of u. In this section, in section 3.2.2, we'll learn how to pick u equals u of x to make substitution work. All right, so there's two different separate things to keep in mind when picking u. So often u equals u of x is inside another function. Remember, substitution is really chain rule applied to integrals, and so g of x in the chain rule is inside the outside function. The same thing here, if it's inside another function. So you need to look out for brackets. So something that's inside brackets. It could be in an exponent. It could be inside a root. And it could be in a denominator. The second clue, all right, let's look back at the theorem right here. So we said you needed g of x to be inside another function. Second clue is this right here. The derivative of what you're picking often appears with the dx. So look at clue number 2, g prime of x dx often is part of the integral. All right, so if you see both, you're probably picking the right u. All right, so let's try here. Example 3.2.3. Evaluate the following integrals. For all of these, if you feel comfortable, please pause the video and try it for yourself. Try to pick u, try to apply it. All right, let's do A. Integral of ln of x squared over x dx. So if I consider clue number 1 and I'm looking for something inside another function, I have ln of x that's inside the squared, and I have x that's inside the denominator. Clue number 2, g prime of x dx is often part of the integral. If I take ln of x, then g prime would be 1 over x, so g prime dx would be this part. All right, so the correct u to take here is ln of x, and then du is 1 over x dx. And so this integral, I have u squared, and then this is exactly du, so u squared du. In cases like this, where you actually have g prime of x dx as is, you don't have to solve for dx and plug it in. You can take everything that's part of g prime of x dx and replace it by du. So all of this gets replaced by du. And then I integrate this, just the power rule, and I get log of x cubed over 3 plus c. All right, let's try another one. I have cosine of root of t. Notice that now my variable is t. It doesn't change anything, t or x or u. It's the same thing. It's just that I chose to call it t. All right, cosine of root of t. I have root of t inside the cosine. So let's try that. What if I take u equals root of t? I need to make sure that my derivative is somewhere too. If I differentiate this is t to the 1/2. So if you don't remember the derivative, you can use it. So it's 1/2 t to the minus 1/2. And so that's 1 over 2 root of t dt. So what I have is close. I'm missing the 2, but I do have this part. So that's perfect. As long as the difference is just one constant, it's going to work out. The constants are no problems for integrals, they just come out. So here, one thing I could do is I have root of t and dt, and so I'm going to keep this, and let me just send the 2 to the other side. So I get 2 du is equal to 1 over root of t dt. All right, so this integral is cosine of u times 2 times du. And so I get 2 Integral of cosine, you need a function whose derivative is cosine. That's just sine. I don't need a minus there. And so the answer is 2 sine of root of t plus c. All right, so there were 2 clues. Root of t was part of cosine, and the derivative is very close to what I have here. All right, it's not exactly, so I ended up with an extra 2, but that's fine. As long as it's a constant apart, it will work out. All right, let's try this last one here. I don't have any brackets, so we said to look out for brackets. We don't have that, but we do have exponents. So the first clue tells me that maybe secant could be right. So let's try it. I'm going to take u equals secant. Du, the derivative of secant, that's secant x tan of x. And so this entire thing is g prime of x dx. So it's perfect. You have secant inside a function, and you have secant x tan x dx outside of it. And so this becomes e to the u, and everything outside is just du. So the integral of e to the u is e to the u. So it looks like nothing has changed, but I did integrate. It's just that e to the x is its own derivative and its own integral. And so now I need to go back to x. All right, let's try one more. What about this one? What about the integral of root of 3x plus 6? All right, now I'm a bit more puzzled. I'm a bit more puzzled because I don't have 2 terms. I don't have something that could be f of g of x and something that could be g prime of x dx. But I do have a root, and I have something complicated inside. So because this is inside the root, by clue number 1, I'll take u equals 3x plus 6 because it's in a root. We could try that. If I take du is 3dx. So I don't have 3 as part of my integral with my dx, but like we said in the previous example, in this example, the fact that I'm just missing a constant is not a problem. The constant will work out. And so here, because the derivative is so simple, I don't need anything more than dx. I'm just going to replace dx by 1/3 du. So this kind of substitution for just a linear function, something that has a graph that's a line, will work if it's somewhere inside your function because the derivative is going to be so simple. All right, so I'm getting a root of u, and then dx is 1/3 du. And so I'm getting 1/3 u to the, this is u to the 1/2. And so I'm getting u to the 1/2 plus 1, 1/2 plus 1 plus c. So I'm getting 1/3 u to the 3/2, 3/2 plus c. And finally, I need to go back to x. So I'm getting 3x plus 6 to the 3/2 plus c. All right, so let's recap the entire method. I have substitution method. First thing you need to do is to choose your u. Choose what g of x is. You look for g of x inside another function, so inside brackets, exponent, denominator, roots, just inside some sort of function. And to make sure the substitution will work, keep your eye out for g prime of x dx. The last example taught us that if you have ax plus b somewhere in your integral, you can try ax equals b for your u. It's going to work out. I'm not sure it's the right thing to do. It depends on how it simplifies your integral, but it's going to work out because the derivative is so simple. All right, then you replace dx by 1 over g prime of x du and simplify. If you see du there, you don't have to do that step. You could just replace the whole du, the whole g prime of x dx by du. Rewrite the whole integral using only u. All right, so at this point, you should have no x's. If you still have x's, you need to keep working to replace it by u. If that's not possible, you picked the wrong u, you're not doing the correct substitution. Once you've written your whole integral in terms of u, you need to integrate with u as your variable. And then once you're done, you should have no integrals. So once you've gotten rid of all integrals, you go back to x, replace u by g of x. All right, so in the next video, I'll show you 2 examples where your first guess of what to take might not be the right one, or there are 2 possibilities, and we'll see how the 2 clues come into play.